Space weather is the field that studies how what's going on the sun affects us here on the Earth in our near space environment and on the space environment on other planets.
For a large eruption, the sun produces a flash of light, which we call the solar flare. It also produces a huge ball of material traveling away from the sun we call a coronal mass ejection. And both of those phenomena can accelerate subatomic particles, which we call solar energetic particles. These three things together make up a solar storm.
A coronal mass ejection, or CME, is an eruption of plasma from the sun that shoots out into space, and it could affect us here at Earth. A solar flare is a huge release of energy that converts the magnetic energy of the sun into heat, into light. It accelerates particles and can really heat up the plasma in order of minutes to over 60 million Kelvin. Solar energetic particles are particles of plasma that are accelerated at the flare site from the energy that's released in the flare. And these particles can be accelerated up to almost 80% of the speed of light.
And a coronal mass ejection, when it's traveling so fast, creates a shock, and that can create solar energetic particles.
Solar flares and CMEs are all driven by magnetic reconnection. This is where the sun turns up the magnetic field, and then it causes oppositely directed magnetic fields to then annihilate. But you can't just get rid of magnetic field. You can't just get rid of energy. You have to convert that energy and transfer that energy into other things, such as plasma motions, accelerating the plasma, heating up the plasma, and also giving out more light.
But a CME is that material and that magnetic field line just getting thrown away from the sun due to this interaction, whereas a flare is the sort of close to the surface phenomena where the twisting and the snapping occurs, and therefore you get all this heat and kinetic energy.